Hello and welcome back. We will finish up 10.2 by talking a little bit about the theory behind what makes a line of best fit the best line that we can find. So we'll start with what's called the residual. And a residual is just the difference between what we observe in the actual data versus what we predict using our line of best fit. So it's just going to be the observation minus the prediction. So we can think of this like an error. So what's the difference between what actually is and what we predict? It's just going to be how far off is our prediction? What's the error here? So for instance, if the predicted weight of a bear with a 40-inch chest is 322 pounds, like we found in the previous video, but we actually go out and tag a bear that actually weighed 334 pounds, then we could find the residual of this. So the observed Y, the actual weight, is going to be 334. The predicted weight was 322. So it means that the residual will be 12 pounds. So essentially, the best that we can do will minimize the residual. So we want as small residuals as we can. In particular, if we want to minimize all the residuals all at once, we want to minimize the squares of every single residual. And there are reasons why we want to do the squares rather than the residuals themselves, but I won't necessarily go into that. So kind of like as a picture here, we can say we only have 4 data points here. The residual is going to be the difference between the observed data, so like the actual data point, and our line of best fit here. So the residual is just going to be the distance from this point down to this line. So this is going to be our residual, but we'll have 4 different residuals here. And we want to sort of simultaneously make them all as small as possible. So what we'll do is for each residual, let's say we have residual 1, residual 2, residual 3, and residual 4, we'll want to square them all and add them up. This is a way of turning 4 numbers into 1 number, and we just make this 1 number as small as possible. Luckily, the computer does all of this for us. And the line of best fit that we saw before, we saw how to calculate the slope and the y-intercept. All of that comes from this right here, trying to minimize these residuals as this 1 number. This is called the least squares. So when the sum of all the squares of all the residuals is as small as it can be, we say that this line has the least squares property. So a regression line or line of best fit is the one that satisfies the least squares property. So this is just a little bit of the theory behind what makes a line a good fit or not. We want to sort of minimize the sum of squares of the residuals so that it has the least squares